Hello everyone, hope you're doing well. In the last video, we went over what a linear regression is and how to form one in our studios. And in this video, we're going to be talking about logistic regressions. So logistic regressions are used whenever you have an outcome that you're interested in that is binomial uh, binary, so it's either one or zero. And that, an example of that would be like either um, developed cancer or didn't develop cancer, or lost weight or did not lose weight. So things where it's either one or the other. Um, and that's compared to linear regressions, which are used when you have a continuous outcome. So um, another difference is that between linear regressions, you get when you use a linear regression, you get a risk ratio as an outcome. Like the coefficients that you get for each variable is a risk ratio compared to when you use a logistic regression, you get odds ratios. So um, to because like the data is going to be similar, I'm just going to be using the same R file, script file to do the logistic regressions, and I'll change the name here, but let's just load in the data. And then let's make for our outcome, let's make a age. So we'll make a new storage object, and we'll make a variable, a binary variable related to age, and we'll just make it if you're over 35, you'll get a 1. If you're less than or equal to 35, you will get a 0. So do that, and we'll use that storage object for the logistic regression. So now let's do Victor. And the format of it is quite similar. So we're going to make a storage object called logistic mod. So short for logistic model. Logit's another way of saying logistic regression. And then instead of using LM, which stands for linear model, we'll use GLM, which is general linear model. And the format is similar though. We just start off with our outcome, which is over 35. And we use a squiggly line, and then we write the variables or the predictors that we're interested in. And this one will do risk curve. And then we'll do family. The next argument is family is equal to binomial. And that just lets it know that we're doing a logistic regression. And then lastly, we just do the data, which is the storage object, the data frame that we're getting our data from. Okay. So now we run this, and we have our logistic model. So the next thing, if you just want to look at if you just want to look at the overall summary of the model, model summary, we just use the summary function. You just want a quick glance to see what the results are. And this gives you the results inside of the console. And it gives you all the data about the coefficients and if they're significant or not. And it gives you some data on the test that you did. Then if you wanted to get a version of the summary that's in a form that can be used in other functions. You could use the glance function like we did here. So we could do logit one. I do glance. So now we could see the outcome in like a data table like this. And then, however, if we wanted to basically check, so this gives you when you do like a logistic regression, you might have like a variable or two that are significant in their association. However, in order for those to be meaningful, the whole model itself has to be significant. And the way that you test that is first you have to run a null model, and then you compare it to the model that we made. So I'll just give I'll just write this out, copy and paste it. So overall model. Yes. So first you have to make a null model from the same data set that we have that we made for the initial model. And then you have to use a package called lm test. And then once you have that, you can do lr test and then do logit mod first, and then you'll do your null mod, the null model second, and you run this, and now we can see here. You could get the likelihood ratio test, which measures the significance of the entire table or the entire model, and you can see here that the p-value is less than 0.05, so this is significant. So, and then you could put this in like a storage object if you needed to. Then we can get we can just get a data table or data frame of just the parameter estimates. Like if you don't want all of the different like estimates and values. So, and it says here Tibble. A Tibble is just like one of these, like a data table that is compatible with the tidyverse functions. So you'll be, if you like use R more often, you might see that word. So I don't know if I introduced it earlier on, but yeah, that's what a table means. It's just like a data table. So and then so it got printed over here, but if you put that into like a storage object, it would be able to come up here. And then you could also just get the 99% confidence interval included into this. So it's the same thing, just now you have the confidence interval printed here. And then lastly, we can use the table regression function like we did here. We could do the same thing to get a nice presentable table that we could see in the viewer. So for logistic regression outcome, and we could just do the table regression and then just include this argument exponentiate, because when you get the model, if you like use the numbers directly in the model, it's not actually the odds ratio. You need to put them into the e power. So you need to put e to the power of the coefficient that you get from the model. So once you do that, you should get this nice table over here, which gives you the odds ratio. So in this case, it's saying for every one increase, one like digit increase in whatever unit, 1 unit increase for risk Earth, you will have a the odds of being over 35 or 1.2 times the odds of being 1 unit lower, something like that. So that's it for the regression models, and I believe that's really it for the statistical testing functions that I'll be going over in this course. But there's going to be couple more videos just about some other useful functions and skills that are good to know in R, including like looping and other data management tools. So thank you for watching this, and I hope you guys have a nice day. Bye.